So for chapter 14.2, we're going to talk about how solution making and crystallization are opposite processes. So initially I have the solute on its own and the solvent on its own, and when it undergoes the process of dissolving, we create a solution. The backwards direction of that is if I have a solution and it then crystallizes, which means it separates back out into the solvent and the solute. So when we have two arrows and both processes can happen simultaneously, like at the same time, we get a situation called equilibrium. Now, initially I could have, my pure solute or my pure solvent, and I can put quite a bit of solute in and I can keep dissolving. But at some point, I'm not going to be able to. So when the rate of both of these processes is equal, so the rate of dissolving is equal to the rate of crystallization, then if I added any more solute to it, I will not be able to dissolve. And this is when we have a saturated solution. So I can't dissolve anymore. I am saturated. Just like if I had a towel and it was saturated with water, it can't hold anymore. It's now getting ready to drip, right? If I haven't yet reached that amount to create a saturated solution, I haven't added enough solute, then what we have is an unsaturated solution. Okay, so the solubility is a term we use, and that is the maximum amount of solute we can dissolve under a given temperature and a given amount of solvent. So here is a solubility curve where I have solubility as my y-axis and temperature as my x-axis. And lots of different chemicals are on here, lots of different solutes, and they have different trends. So in general, for most of these, as I increase the temperature, I can increase the solubility. So if we look at potassium chlorate here, at 30 degrees Celsius, I can dissolve 10 grams of potassium chlorate. But if I increase my temperature to, let's say, 90 degrees, I can now dissolve like 45 grams of potassium chlorate. So, and we know that, right? If I want to put some sugar in my coffee, I have to heat it up if I want to it needs to be warm. I can't do it with an iced coffee because the sugar won't dissolve as easily. So I want you to know that solubility, these solubilities curve, these are theoretical limits based off of different substances. When I'm talking about saturated versus unsaturated, this is my actual solution that I'm created. Have I reached the solubility limit yet or not? So if I have, then my solution is saturated. If I haven't reached my solubility limit, then I am unsaturated, meaning that the amount of solute that I have in my solution is less than the maximum amount, right? Less than the solubility limit. So here are my theoretical, right? This graph shows my theoretical limits, but let's say I'm in the lab and I make, I heat up my solute or my solvent into 50 degrees Celsius, and I put 10 grams of potassium chlorate in it. So I know that at 50 degrees Celsius and 10 grams, I am below this line, meaning that I have created an unsaturated solution. If I then added more and I added maybe like 18, now I am saturated. I can't dissolve anymore. I'm at my maximum limit. I could also put, like 25 in. So how does that differ? Well, if I put 25 grams in of potassium chlorate at 50 degrees Celsius, only 18 will dissolve. So the solution that I've created is saturated, and I have excess potassium chlorate that is going to sit at the bottom. So the solution I've created is saturated, and I just have extra sitting in there that is a solid and undissolved. All right. So there's one more case, and I want to really lean into the fact that this is very rare. Okay, so to start off, most often you'll see saturated and unsaturated solutions. The third type is called the supersaturated solution, and this is one where the solvent holds more solute than it can at that temperature. So how does this process happen? Basically, let's use our potassium chlorate situation again. Let's say I'm at room temperature So at room temperature, about 20 degrees Celsius, the maximum I can add, my solubility limit is about 7 grams of potassium chlorate. So if I put in, let's say 20, only 7 would fit. So what I could do is I could heat it up to a temperature where 20 grams can fit. So we can see that starts to be around 50 degrees Celsius. So let's say I heat it up to 60 just to be safe. I heat my solution up to 60, I put in my 20 grams. All right, then what I do, and once it gets all dissolved, we're good. I then let it cool, for then it cools down. And if I don't touch it or anything, it will stay in solution. And I cool it down to room temperature, now I'm up here. Okay, and I have dissolved. Now these solutions are very unstable because they are holding way more solute than they should. And so crystallization, right, I have way more solute than I should, so my crystallization process really wants to happen. And so what happens is if I add like a little crystal, I scratch it, I bump it, I knock it a little bit, all of that extra 13 grams of potassium chlorate are going to crystallize out. So here we have our solution. We cooled it off. We add a single little crystal to it, and then it causes this fast crystallization process to happen. And then our extra mass is down below. And then any solution that I have left, or that saturated solution left, will sit still in there and it will be saturated. These are very uncommon and don't happen a whole lot in nature. They really require that you put, you have to do this whole process. I have to increase the temp, create a saturated or, add a lot more solute, and then I have to cool it off. So it involves a heating and a cooling process. If the problem does not state that there is a heating and cooling process, your solution is not super saturated. So once again, very rare, and it has to undergo all of those steps.